So this chapter is chapter 5, which is descriptive statistics. Yeah, in short, which is descriptive statistics is summarizing the data in a compact, easily understood fashion in a way that we could like start to see the structure, for example, of the data, not analyzing properly, but seeing the properties of the data set we are going to use. So for showing what descriptive statistics is and how can we perform them in R, the book is using a couple of data sets. One is called AFL Finalist, which contain the names of the teams played in a season, or well, in a period between 1987 and 2010. And the second data set is called AFRL Margins, which is the number of points annotated during the 2010 season. So this data set is, we upload the data set, and where we are going to be using a library called LSR, constructing specifically for this book. Yeah, this library contains a function called that is showing us the columns that contains each one of our data set. Yeah, with the function head, we are going to start exploring or seeing what the data set contains. We can see that, for example, the margins dataset contains just like numbers, which are the number of points annotated along the season. And well, the finalist dataset contains names of the teams that play during the period we're seeing. So, but these numbers are not saying properly, or they are not saying nothing. Basically, if we saw them like a raw. So that's why we have to start like extracting some properties of the data. The most like typical or classical way to start like looking or visualizing the data, the structure of the data, is plotting them in histograms. R has a function called hist that is at least easy way for producing an histogram, a simple histogram. And here, for example, we can start to see some of the properties of the dataset. For example, that annotating like more than 100 points is like very, very infrequent, while annotating, for example, like between 1 and 0 or 40 points is the most frequent thing. So yeah, this is a way to start visualizing or extracting some kind of information from the data rather than just having numbers in a table. But yeah, we also describe the data using the measure of central tendency that probably you all know. But yeah, the book is retaking these concepts, saying that they are like the most important things to describe a data set, which is the mean, I'm sorry for the type, the median and the mode, and introduce a concept which is trimmed mean. So the book presents the formula for the mean. This formula is not properly from the book, because not from the book, but it's exactly the same. The only difference with the book is the authors are using capital X with bar rather than this, what is the name, minor. This is small x. The book is using the capital letter. But they are saying that along the book, we are using this notation where this X with a sub-index Y means the I observation or the n observation of the variable X. The summatory is the summatory, and the capital letter with a bar is the mean. But fortunately, we don't have to do this by hand, as R have these useful functions, mean for calculating the mean and median for calculating the median. But here we have like a kind of our first dilemma, which is like what we are going to use, the mean or the median for describing our data set. What's the difference between these two? And in here the author says or express that the mean is the average of all of your data, while the median is the number in the middle of all your data set. Which one we are going to use depends of the goals we have, or what we want to achieve, and the type of data we have. For example, in here they are presenting or saying three types of data. One is the nominal scale data, the ordinal scale data, for example, like rankings, and the third one, which I think is the most common, I don't know in psychology, but I think is another way is the more common, the interval and ratio scale data. And it says, for example, for nominal data is not like very, or cannot we use the mean or the median, and rather we can use, for example, the mode for describing the nominal data sets. In ordinal data, for example, the median makes more sense for describing this type of data, as it can provide information, for example, about which number are bigger in a ranking, for example. But the mean doesn't have so much sense, but can be used, but doesn't have so much sense. And for interval and ratio scale data, both the median and the mean is acceptable. Which one we are going to select depends of our goals. It says that the mean has the advantage that use all the information of your data, which is useful when you don't have a lot of data. I am not sure about this, but yeah, the main advantage of the mean is that it uses all your data. But their disadvantage is that it's very sensitive to the extreme values, as we can see, for example, in this figure. This figure is graphically illustrating both concepts, the mean and the median. The mean can be seen as these blocks or squares represent the distribution of our data set, and the mean could be seen as the balancing point of our data set, while the mean can be seen it represents the median or the middle point of the data set. As we can see here, the median is very sensitive to the extreme values and is affected for the shape, for the distribution of your data, which is the types of distribution we're going to, some are concepts that we are going to see in next chapters, but initially in here we are saying that, for example, in data with for a long tail, for example, the median could be very affected for these extreme values. Well, the mean is the middle data is not sensitive to extreme values, but the problem is that it's not properly using all the data. Yeah, the next thing of the book is presenting is a concept called trim mean, which means that cutting these extreme values that affect the mean value. I didn't know this, but the mean function has an argument called trim, where you can say, you can cut or remove, for example, 10% of your data, the most extreme values, or the 5% of your data, the most like extreme values. The only thing I can see, or at least in the book, they doesn't present a way just to remove, for example, in one extreme of the data set, which I think will be more useful. But yeah, this, I mean, trim argument is cutting the values in both tails of your data set. Yeah, and here is, for example, illustrating what is the impact of doing this. The median, yeah, here we construct a small data set with an obvious outlier. Well, it's not so obvious, but with an possible outlier, which is -15, and the mean of the data set, this data set is 4.1, while the median is 5.5. If we remove these extreme values, we can see that the mean is equal to the median. But yeah, we can set the different threshold to remove data. What else? We have the mode measure. We can see the using the function table, we can see the frequency of each one of the teams that play during the season or during the evaluated period. And this package contains RBase doesn't have a function for calculating the mode, but this ISR function contains this function, which is mode off, and for calculating the mode, and max freq for obtaining the frequency. Yeah, this is for expressing the central trend of the dataset. But for describing a dataset, we also want to express the variability of our dataset, and there are several ways to do this. The most basic one is the range. We have this one, the range function, that present like or show the mean and the max values of the dataset. But definitely is not something that people use very frequently. We have the interquantile range, which, yeah, a quantile or a percentile is like, this is defining with an example. The 10th percentile of a data set is the smallest number x, such as the 10% of the data is less than x. We can see that it's like a fraction of the data set, comparing with the whole data set. I know that makes sense, but possibly you know what is. Yeah, the second example is more illustrative in the way that the median of the data set is the 15 quantile or percentile. For estimating or getting the interquantile range, we have this function which is quantile, and we can say that with this argument probes the quantile we want to obtain. Yeah, for example, here first we have, for example, the median of the data set, which is 30.5, and when we use the function quantile with probes 0.5, gives us the same value as the median. But also we can obtain, for example, the 25% and 75% quantiles, but by using this argument. Yeah, if we subtract the bigger quantile from the small quantile, we obtain the interquantile range, but it also can be obtained using this IQR function. Yeah, another measure for expressing the variability of our data is the mean absolute deviation. The mean absolute deviation is the yeah, what is the distance? The absolute distance of each one of our points from the center of the data. The center can be defined either by the median or for the mean, depends on the analyst. But yeah, it is defined as the absolute distance, or yeah, deviation from this center point. So for illustrating here, the author is presenting a tiny data set of just 5 observations. And here we have the values, and just like for obtaining the absolute deviation is just like subtracting the mean from the value and then convert them to absolute values. I mean, the negative values are positives because it's just like how far we are from the center. So just, yeah, here the negative values are converted to positives. And then for obtaining the mean of the absolute deviations, we just like take these the absolute deviations and divide it for the number of observations. So yeah, here's how we obtain the mean. Yeah, here is the mathematical formula for this. Something the author raises is that R tend to use MAD for refer to the mean or the median absolute deviation. That's why in this package they use the notation AAD, or average absolute deviation, for the mean absolute deviation. Yeah, so just to keep like MAD for median absolute deviation. So what, yeah, here is an example of how we can do this manually. Just like we have the data set, obtain the mean of the data set, and then subtract the values from the mean. And what else? Yeah, calculate the mean of the values, and yeah, this is calculating by I mean, each step by step. But yeah, the ESR package has this function AAD, which and we can obtain the same result. And yeah, the variance. Yeah, then the next measure is the variance. Yeah, the variance is the square values of the deviation, or the here, yeah, we have the deviation for the mean, and we square them to obtain this square deviation. And then again, we yeah, this is the variance. Yeah, we divided between the number of observation to obtain the variance. And yeah, we can this kind of construct our own function, or our own formula, sorry. And here, or we can use a function called bar. And in here, something important, maybe you know, is that for calculating the variance and the standard deviation, by default R uses the, rather than dividing between the number of observations, it divides between number of observation less 1, which is a formula for samples rather than populations. The book says that this is going to be explained more deeply in later chapters, but at the moment it's something like to consider that for using the bar function, yeah, R is using the samples formula rather than the population, which indeed is more appropriate for our data set, as is just like five observation from our whole data set. Yeah, but this is the reason why we doesn't obtain the same results using this with our own formula and using the R function, R base function. But yeah, could we say that possibly R is correct? And yeah, one problem with the variance is that it gave us like very large number that are almost, or they are non-interpretable or non-easily interpretable, as they are not in the same units that we had at the beginning. So that's why it's usually preferably using standard deviation. The author says that the variance has a lot of mathematical valuable or worthy properties, which the author says are not discussed in the book, but it says that has a lot of like worthy properties, and is usually used more by statisticians or mathematicians, but for like more normal or applications, is more common to use the standard deviation. And the standard deviation can be seen as the square root of the variance. Here we have the square root of the variance, and here we can start to see that there is a difference in the formulas for estimating the standard deviation for a population or for a sample of the complete population. And there is also a function for obtaining the standard deviation, which is SD. By default, as I said, R is giving us the results using the formula for this sample. Yeah, interpreting the standard deviation like give us more like reasonable numbers, but it's complex because the standard deviation is derived for the variance, and the variance is a quantity that has no properly meaning that makes sense for humans, and therefore standard deviation doesn't have a simple interpretation. As a consequence, the standard deviation are interpreted as with rules. In general, we could expect that 68% of the data fall within one standard deviation of the mean, while 95% of the data we can expect them to fall within two standard deviations of the mean. Almost all the data, 99.7% of the data, to fall within 3 standard deviations of the mean. It says that this rule works relatively well most of the time, but it is not exact because it is calculated on the assumption that the histogram is symmetric and bell shape with the proper term is normally distributed, it's bell shape. But this is not always the case, and in these exceptions, we have to be careful how we are going to interpret standard deviation. But this is something that is going to be discussed more deeply in chapter number 9. And which measure to use? It says that it depends on the goal or your goals and type of the data you have, but basically the interquality range and the standard deviation are the most common measures used to report the data for describing the central trend of the data and the spread or the variability of the data. But we have to be careful, but there are situations where other measures are used, and be careful how we are going to interpret this data, and be careful with the assumptions we are taking. And the book it continues, like there is where is the book? Yeah, here's the book. The book continues, has some, I haven't read them, but has more things. For example, the forms of the types of the types of distribution of the data, like for example here. The next part is how we are summarizing the data using the summary function, summarizing the data frame. There are, and also this using this function describe, which is like obtaining all the measures we saw previously, but just from a function. I think I haven't seen it, but is this function before, possibly is from this package, but is describe statistics for each one of the groups. If we have groups in the data, describe the same statistics both by groups. And the function aggregate and standard scores, for example, the C scores, correlations, the correlation coefficient, interpreting correlation, Spearman rank correlation. I don't know. I think it's worth it to spend another session for finishing this chapter, but I don't know. What do you think? Yeah, it's fine for you, Federica. Okay. I know. What do you think, Priyanka? We could spend another session finishing this chapter, or we move forward? to the next chapter.
Esmeralda,
Yeah.
I think so it's worth it to do the other part of the chapter. So if you'd like to do that,
Yeah,
you can do it. Would you
yeah,
like to do that? Yeah. Okay.
yeah. I can do that. For the next session, we just need to say Eric Yegon that the chapter he's presenting is going to move a week. But yeah, I can present the rest of the chapter for the next week.
Okay. Yeah.
And I think Priyanka is not here.
Yeah, no, I am actually here, but I got called into another meeting. So we have, so many things going in parallel and a proposal going on. So last 15 minutes I've been out.
Okay.
Like out as in I'm here, I can hear you, but I'm also on another call.
Okay, no problem. So yeah, I was saying that yeah, possibly Federica agrees with we can spend the next week for finishing this chapter. Will be worth it because there is like, for example, correlation concepts that could be good to see. I can present them the next week, but we have to notify to Eric that her chapter, presentation is going to move a week. What do you think?
I'm sure it's okay.
Sorry. Yeah, it's okay.
Okay. Then see you the next week.
Yeah, I don't know if Eric is gonna be able to make it. I highly doubt. So we might have to, split that. I mean, I would imagine that, one of us should be ready for next week's topic. Because I did ping him. I have tagged him already a few times, but I've not seen him respond.
Okay.
Eric Yegnon, who has signed up for the next chapter. So just throwing that out. Yeah.
Yeah, that's okay because Esmeralda is going to finish this chapter next week, and then we arrange for the following weeks. I don't know.
Okay. Cool. Sounds good.
Okay. See
All
you
right,
next
thank
week.
you. Yeah, see you all next week. Bye-bye.
Bye.
Thank you.
Thank
Bye.
you so much, Esmeralda. Bye.
Bye.